Welcome back. This session we discuss how to get the sum of the first n terms of an AP and the first n terms of a GP. So let's demonstrate how we do that. Sum of the first n terms of an AP. So AP means arithmetic progression or arithmetic series. So let the sum of the first n terms of the AP be given by capital S sub n. That is to say, Sn equals to A plus D plus A plus 2D plus A plus 3D plus A plus n minus 1D. So that's the first n terms. Now for simplicity, let the last term, which is the nth term, be L, i.e. L is given by A plus n minus 1D. So this means Sn will be A plus D plus A plus 2D plus A plus 3D plus L minus 3D plus L minus 2D plus L minus D, then plus L. So I'll call this one equation 1. So we can also obtain this sum by rewriting the terms in this equation 1. So we also obtain the sum by adding, starting from the last term. That is, Sn will be given by L plus L minus D plus L minus 2D plus L minus 3D plus other several terms plus A plus 3D plus A plus 2D plus A plus D plus A. All this one equation 2. So adding equation 1 and 2, we get, so you see we are going to have L plus A, this first corresponding terms in these two summations. So we'll have 2Sn, because Sn plus N, Sn is 2 Sn, A plus L And then AD, so this term, AD plus L minus D will give us A plus L. So we get plus A plus L. Then L minus 2D plus A plus 2D will give us another A plus L. A plus 3D plus L minus 3D will give us A plus L plus A plus 3D plus L minus 3D gives us A plus L, then A plus L, then A plus L. And the last term, A plus L, just the same as A plus L. And if you count this number of terms, you get that there are n values. So from A to the first, second, third, up to n. So there are n such n A plus L values. So this means 2Sn is n multiplied by A plus L. So n into A plus L, so which means that Sn alone will be n over 2 into A plus L. So this is what is giving us the sum. So substituting L equals to A plus n minus 1D, we have Sn equals to n over 2 into A plus n minus 1D, and this simplifies to n over 2, 2A plus n minus 1 times D. So this is the formula for finding the summation of the first n terms of an AP. Let's also discuss the formula for finding the sum of the first n terms of a GP. So sum of first n terms of a GP. So we know that let the GP be given by A plus AR plus AR squared plus AR power 3 plus AR power n minus 1, etc. So let the sum of the first n terms be Sn, where the Sn is given by Sn is A plus AR plus AR squared plus AR cubed. I remember the nth term of an AP, of a GP is given by AR raised to n minus 1. So call this one equation 1. So multiply 1 by R to get R Sn equals to AR plus AR squared plus AR cubed plus AR power 4 all the way plus AR power n. So this is what is going to be called question 2. Then subtract equation 1 from 2. So 2 minus 1 gives RSN minus SN. So this was going to happen. You see, this and this will cancel out. This and this will cancel out. This and this will cancel out. We are sure the next term here will be A R power 4, so this will also cancel out. We are sure that before this A R power n, we have A R power n minus 1. So this and this cancels out. So we'll remain with A R power n minus A. But the only A is the only term that remains in equation 1. Question 2, you have A R power n. So which means R minus 1, you factor out Sn, will be A into R power n minus 1, which means Sn is A into R power n minus 1 divided by R minus 1. So this is formula 1. Which applies for R greater than 1. Or simply magnitude of R greater than 1. So for if we also do question 1 minus 2, so we'll have Sn minus R Sn equals to A minus A R power n, which will be 1 minus R. Sn equals to A into 1 minus R power n, which implies Sn is given by A 1 minus R power n over 1 minus R. And this applies for R less than 1. So therefore, these are the two formulas that helps you to get the values of the sum of the first n terms of a geometric progression. So examples: find the sum of the first 10 terms of the series 5 plus 11 plus 17 plus 23, etc. So the first thing is to determine whether you are dealing with an AP or a GP. So solution, we see that 11 minus 5 is the same as 6. 17 minus 11 is 6. 23 minus 17 is 6. So this means D is 6. So we are dealing with an AP. So here A is 5. And we know that Sn is given by n over 2 into 2A plus n minus 1 D. This by definition. Now we are indexing the sum of the first 10 terms. So n is 10. So S10 will be 10 over 2 times A, which is 5, plus 10 minus 1. D is given by 6. So S10 will be 5 into 10 plus 9 times 6. So 5 into 10 plus 54. 10 plus 54 is 64. So 5 times 64, which gives you 320. Example 2, find the sum of the first 8 terms in 3 plus 6 plus 12 plus 24 plus other several terms. If we try 6 minus 3 is 3, 12 minus 6 is 6, so 3 and 6 are different. So probably this is not an arithmetic progression. But if we try 6 over 3 is 2, 12 over 6 is 2, and 24 over 12 is 2. So this tells us that we have a common ratio, which is 2. So we are dealing with a GP problem. So we have A, first term is 3. Now Sn, R is greater than 1, so will be given by Sn is A into R power n minus 1 divided by R minus 1, since R is greater than 1. So we'll have the sum of the first 8 terms. So S8 will be A, which is 3, into R2 power 8 minus 1 over 2 minus 1, which will be 3 into 256 minus 1 over just 1. So 3 times 255, and this gives 765. So this will be the solution. So the sum of the first 5 terms of an AP is 75, and that of the first 8 terms of the AP is 168. So A, find the first term and common difference. B, hence find the 15th term of the series. So here we are dealing with sums of AP. So write the formula for sum of AP. So Sn is n over 2 into 2a plus n minus 1 d by definition. So when you are told sum of the first 5 terms, so n is 5, should be 75. So S5 is the same as 5 over 2, 2a plus 5 minus 1 times d should give us 75. So which means 5 into 2a plus 4d is equals to 2 times 75, which is 150. So 10a plus 20d equals to 150. So divide through by 5, we have 2a plus 4d equals to 30. So which can as well be reduced to A plus 2D equals to 15 for this equation 1. And then sum of the first 8 terms is 168. So S8 is 8 over 2 into 2A plus 8 minus 1 times D should be 168. So this will be 4 into 2A plus 7D equals to 168. You can divide through by 4 to get 2A plus 7D equals to 42. Call this one equation 2. So from 1, A equals to 15 minus 2D, so call it 3. So just solving 1 and 2 simultaneously. So substitute 3 in 2 to get 2 into 15 minus 2D plus 7D equals to 42. So I'll have 30 minus 4D plus 7D equals to 42. Minus 4 plus 7 is 3. 42 minus 30 is 12. So D is 4. Now we can get A from equation 3 to be 15 minus 2 by 4, 15 minus 8, which is 7. So therefore, first term is 7 and common difference is 4. Part 2 of the question was to find 15th term of the series. So we know that nth term of an AP is given by A plus n minus 1 D. So 15th term, n is 15, will be A plus 15 minus 1 D, but A is given as 7 plus 15 minus 1 times D is 4. So 7 plus 14 times 4, 14 by 4 is 56. So we have 7 plus 56, which will be 63. So therefore, the 7th term of this AP is 63. Then lastly, find the sum of the first 5 terms of the series 48 plus 24 plus 12 plus other terms. So clearly, this is not an AP because 48 minus 24, D24 minus 40 is different from 12 minus 24. So we have 24 over 48 is a half, and 12 over 24 is also a half. Remember, when this is the first term, T1, this is T2, this is T3. So when you want to get the ratio, is T2 over T1, T3 over T2. So this is the structure. So and these two should always be the same, because this will give you R. So R is a half, So R is a half, which is actually less than 1. So Sn will be given by the formula A into 1 minus R power n over 1 minus R. The interest of the sum of the first 5 terms. So S5, A in this case is 48, into 1 minus 0.5 power 5 over 1 minus 0.5. So we have 0.5 power 5, 1 minus answer. So this will be 48 times 0.96875 divided by 0.5. So which will be 46.5 divided by 0.5 to give us 93. So this is the sum of the first 5 of that given series. So lastly, find the sum, find the 5th term of the sequence 128, 64, and 32. So clearly, 64 over 128 is the same as 32 over 64, and this gives us a half. So this is the common ratio, and this means this is a geometric sequence. Whose nth term is a power r minus r is power n minus 1. So 5th term will be a, which is 128 times a half raised power 5 minus 1, which will be 128 times 0.5 power 4, and this gives you 8. So that value is 8. So that's how we solve those problems on summation involving APs and GPs. Thank you.